Hello everyone and welcome to the walkthrough for worksheet 4A. We just took, or maybe you will take soon, the third exam. So this is the fourth chapter, and this chapter is going to be talking about a bit more factoring and advanced equations. So we're just going to get a little bit trickier with these, okay? So on this worksheet, the beginning of it, it says we're just going to be solving the equation, showing the appropriate work. So it's basically just factoring, and then it's all set equal to 0. So once you factor it, you do all the factoring, at the end it's just another little step added to it, and then it's all done. At the end of all these problems, you should have x equals something. So how do you make this whole thing equal 0? Well, you plug in this x or you plug in this x, and that's how you get your answers. So I'm going to do the first 5 problems, and then I'm going to do a couple of the hard ones at the end, and that's going to be it. Once again, the answer key is on Schoology. All the problems are worked out, and I think I did a pretty good job showing all my work. So look at that, look at it real close, and if you just can't figure something out, just email me and I'll let you know. Okay, so let's look at number 1. It says give simplified answers, not rounded decimals. So basically all these shouldn't have big long strings of decimals after them. So number 1, we're going to factor this by making our diamond problem over to the right. 4x squared times 2 is 8x squared, and that's how I get the top. The bottom is just 9x. Then we think of 2 things that multiply to make an 8 that add up to a 9. Well, that's 8 and 1, and that's what I have here in red. I replace the 9x in the middle with the 8x and the 1x, and it doesn't matter which order you plug them in. I could have had 1x first and then the 8x, but either way is fine. So then I put parentheses around the first 2 things and the second 2 things, and I just factor out what's common. So for the first one, 4x is in both of those, so that's what I'm going to divide both of these by. And that goes out front. And then the second one, there really isn't a common factor, but you have to factor out something. So the thing that you can always factor out is a 1. So I'm going to factor a 1 out of both of these, and that goes out front. And it doesn't really change much inside the parentheses, but it gives me something. So now the x plus 2 in black and the x plus 2 in black, those match. And if they don't, you screwed something up and you got to go back and find your mistake. Those should always match at this step. Okay, so I write that down, x plus 2 on the bottom in parentheses, and then the coefficients, the things in front of the parentheses, I have a 4x, and on the other one I have a plus 1, so that becomes my second set of parentheses, 4x plus 1. So 4x plus 1 times x plus 2, and then I bring down the equals 0 part again, because I didn't really need it up to this point. So now, what this means is we have 2 things multiplying to make a 0. So that means either one of these could be 0. So I'm going to find out what makes my first set of parentheses 0, and I'm going to find out what makes my second set of parentheses 0. Well, the second set of parentheses are really easy. What plus 2 is 0? Well, that'd be negative 2, so we say x equals negative 2. On the second set of parentheses, that's a little trickier. We have 4x plus 1, and we need to figure out what we would plug in for x to make that whole thing 0. Well, if you don't know, if you can't figure it out in your mind real quick, just set it equal to 0. So I put 4x plus 1 equals 0. I subtracted 1 to the other side. I divided by 4. I got x equals negative 1/4. So my 2 answers, and there are 2 answers to this because it's quadratic, are negative 2 and negative 1/4. So 2 different numbers you could plug into this for the x's, and at the end it would spit out a 0. So that's what we get. Okay, let's look at number 2. So number 2 is one of these special ones that are going to keep coming up over and over again. If you can remember this rule, it makes things so much faster if you can just kind of recognize, oh, I have an x squared, I have my number out back, but I don't have my middle term, so that means it canceled. So I know I'm multiplying conjugates here. Okay, so let me explain what all that means. So at the beginning of this problem, you might recognize that both of these have a 9 in them. I like dealing with a lot smaller numbers than bigger numbers whenever I can. So I divided both of these by a 9 to start the problem, and I'm gonna ignore that 9 until the very end of the problem. Okay, so that 9 I bring out front, and I'm just gonna factor x squared minus 9. This is really tricky, and a lot of people goof on this because we have an end term, we have a beginning term, but we don't have the middle term. So I do my -9 times my x squared, and that goes on top of my diamond problem. There is no middle term, so I have to put a 0 on the bottom of that diamond problem. And that's where people goof. They think it's the -9, they think it's the x squared. They don't know what to put there. So it's 0 because it's just not there. So now we have to think of two things that multiply to make -9 that add up to a 0. Well, you get 3 and -3. And now I put those two things in the middle because there is no middle. So I put them in the middle and I group them together with some parentheses. The first set of parentheses, I factor out an x. Second set of parentheses, I factor out -3. So we get x plus 3 in black. So that's one of my parentheses. And then the other one is x minus 3 because that's the coefficient. So you end up getting x minus 3 times x plus 3. If you notice, both of those are the same exact thing, except one's minus, one's plus, and that's what we're calling conjugates, okay? If we multiply these, the middle term will always disappear, and that's kind of the special case that we've been talking about. Okay, the 9 I pulled out front, I drop it down to this step because it's still there, but ultimately it's not really going to matter because we have three things multiplying here, a 9, an x minus 3, and an x plus 3. They equal 0. That means any one of these three things could be 0 to make it the whole thing 0, except 9. Well, 9 is always 9. 9's never going to change. It doesn't have an x or anything attached to it. So I'm just going to ignore that for now. So x minus 3, how do I make that clump 0? Well, you would plug in a 3. You get 3 minus 3 is 0. So the first x is just positive 3. Second set of parentheses, x plus 3. Well, what number plus 3 is 0? That's just -3. So my two answers for this are positive 3 and -3. And that's what I circle down here at the bottom in green. Okay? All right, let's look at number 3. So number 3, this is going to be a bit of an interesting one. And the reason this one's interesting is because on the right side, we have it set equal to 30 and not 0. That's okay. All you got to do to fix that is subtract the 30 over to the other side and get your 0. So I subtract 30 to the other side and get -36 on the left with that 25x squared. Well, this is very, very similar to the last problem we just talked about. I'm going to show you another way to do it now, okay? So if I notice there is no middle term, there's no just regular x, I do have my first term and I do have my last term. Okay, so what I'm going to do is I'm just going to square root the first part, and I'm going to square root the second part, and I'm just going to come up with the conjugates that way. This is the fast way to do these problems, okay? So if I square root 25x squared, square root 25, you get a 5. Square root an x squared, you get an x. So the square root of 25x squared is just 5x. Now I'm going to do the same thing for the 36. I'm going to ignore the negative in front of it because you can't take the square root of a negative. So we're just going to square root 36, and that gives you a 6. So I have a 5x and a 6, and I'm going to make my two conjugates based off of that. Well, the 5x is the beginning part, so 5x plus something, 5x minus something. The negative, or the 6 is the end part, so plus 6 minus 6. And if you notice, we have two things that are exactly the same. The only difference is one's plus and one's minus. So we have 5x plus 6, 5x minus 6, and there we go. So now all we got to do is figure out what makes this whole thing 0. So if you put 5x plus 6, set it equal to 0, you'll find that x equals -6/5. And then the same thing with the negative version. You end up getting x equals +6/5. So same exact thing as I was doing on number 2, but this is the very, very sped up, I understand this really well version of number 2. You could do this problem exactly like we did number 2 and set up the diamond problem and do the parentheses and factor stuff out, but I promise you'll get the same thing as I did, just not as quick. Okay, let's talk about number 16. Well, number 16 is an interesting problem because on the left side we have the whole thing in parentheses and being squared, and on the right side we don't have a 0, we have a 16. So if it's set up like this, there's a couple ways to do it. You could FOIL out the left side do 3x plus 2 times 3x plus 2, get a big mess, subtract the 16 over, factor whatever you have there, and we could do it that way, and we would get the same answer, okay? But the slick way to do this is to recognize, hey, the left side's being squared. I can undo a square by square rooting it. So that's what I did here in red. I square rooted the 3x plus 2 squared to get rid of the square. And if I do it to the left, I have to do it to the right. So I square rooted the 16. Well, if you square root to the left side, you just get 3x plus 2. The squared and the square root cancel each other out. If we square root a 16, we get a positive 4 and a negative 4. We get two versions, and the reason we get two versions is because negative 4 times negative 4 is positive 16, and positive 4 and positive 4 make positive 16. So you got to have two versions, and kind of the way you know that is at the end of this problem we should have two answers. If we just do positive 4, we'll only have one answer. So from here, I split it up into two versions. I did the 3x plus 2 equals positive 4, and then I did 3x plus 2 equals negative 4. I'm just going to solve these two separately and get two different answers. So the blue one, subtract 2 from both sides, divide by 3, you end up getting x equals 2/3. That's done. That's pretty easy. The green one, subtract 2 from both sides, you end up getting 3x equals negative 6. Divide by 3's, you end up getting x equals negative 2. Now that is done. And like I said, that was kind of a slick trick in order to get that answer a bit quicker than it would be the other way. All right, let's talk about 5. Now, 5 is going to, you might hate 5, but let me show you how to do 5. So 5, I started by making a diamond problem, okay? I did x squared times negative 4 and get negative 4x squared. On bottom, we have negative 2x because that's the middle term. Now, I tried to think very hard of two things that multiply to make a 4, negative 4, that add up to a negative 2. Well, 4 and 1 will never make a negative 2, and 2 and 2 will never make a negative 2. So there's really no way to multiply two things to get negative 4 and add them up and get a negative 2. So if there is no way, what you have to do is bring out the biggest tool in the toolbox that you have. This is the quadratic formula. Miss Montgomery, who used to teach here, she taught here for a long time, probably 10 years. She came up with a really, I think clever way of memorizing this formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the way she said to memorize it was there was a negative boy, b is for boy, who couldn't decide is the plus or minus, whether or not to go to a house party, and I guess the square root's the house. So he decided to be a square, and that's b squared, and miss out is the minus sign, on 4 awesome chicks. So for the A and the C. And this all happened before, and I guess that's the division, and then on the bottom, 2 a.m., and that's 2a. So if that helps you memorize it, cool. If not, then just memorize it your way. All right, so what I'm going to do is I have an A, a B, and a C, and that's kind of what I did in blue, red, and green up here. So the A is the coefficient of the x squared, B is the coefficient of the x, and C is the just ending term, okay? So I plug in A, B, and C into there, and I get something like this. You got to be very, very mindful if it's a negative already and you're plugging it into something that's negative, the negatives cancel out and it becomes positive, so you got to be careful of that. So I plug all that stuff in. You end up getting 2 plus or minus the square root of 20 over 2. Well, I can reduce the 20, and I kind of did that over here on the right. Square root of 20 can break up into the root 4 times root 5, and the square root of 4 is just 2, so we get 2 root 5 ultimately, and that's what I have here on this one. And now the plus and minus, that means there's two versions of this. So kind of like on the last problem, we're going to split this up into two versions, a 2 plus 2 root 5 divided by 2, and a 2 minus 2 root 5 over 2. So if I do that, we get 2 plus 2 root 5 over 2. I can divide both of these things by 2, and that's what I ended up doing. And I got 1 plus root 5. And then on the minus version, same exact thing, I get 1 minus root 5. So these are my two answers, and I'm good to go on that. Okay? Okay, so let's jump down to number 10. Okay, number 10 I picked just because something goofy happens. So I moved everything on this problem at the very beginning over to the left. So I subtracted x over there and I added 4. So you end up getting 2x squared minus 1x plus 4 equals 0. Well, I set up a diamond problem and I got 8x squared on top and negative just 1x or negative x on bottom. So two things that multiply to make an 8, positive 8, that add up to a negative 1. Well, I can't think of anything because the factors of 8 are 1 and 8 and 2 and 4. There's none of those are going to add up to a negative 1. So what I did is I recognized, oh, I got to use the quadratic formula. Gosh darn it. So I put the A in blue, the B in red, and the C in green. I plugged all those in right here, and I reduced and did all my stuff I needed to do. I got 1 plus or minus the square root of negative 31 divided by 4. Well, you cannot take the square root of a negative number because there's no number in the world that if you square it, you'll get it negative, because negative times negative is positive, positive times positive is positive. So there's no way to do that. Excuse me. So what we say is there is no solution to this, no real solution, so we can't do it. So we just leave it alone. Okay. All right, let's talk about number 15. Number 15 is extremely hard, long problem. But let's go through this and see what we get. So on this one, I kind of broke this into two parts. I have a top of the fraction and a bottom of the fraction. I'm going to get the top of the fraction all combined to make one fraction. I'm going to do the same thing for the bottom. And then I'll have fraction divided by fraction, which I can do keep, change, flip. Okay, so that's the whole, I guess, mentality I had going into this problem. Okay, so on top we have 2 over x plus 1 over x plus 1. Well, I need to make the bottoms the same, and they are not the same right now. So I'm going to multiply the left fraction by x plus 1 over x plus 1. Multiply the right fraction by x over x. You end up getting this. The bottoms match, so I combine the tops. You end up getting 3x plus 2 on top, which is what I wanted. Okay, this is done for now. Okay, I did the bottom similar way. I had to turn the 2 into 2 over 1. But now to make the bottoms the same, I only have to multiply the 2 over 1 by x plus 1 and x plus 1. That's what I've done here. Now the bottoms match exactly the same, so now I'm going to add the tops, and you get 2x plus 3. So from here I have fraction divided by fraction. I kind of wrote them sideways instead of on top of each other. I like it this way, but whatever you like, do it that way. So then I do keep the same first fraction the exact same, change division into multiplication, and then flip the second one over. You have an x plus 1 on the bottom left and an x plus 1 on the top right, so those cancel off, which is nice. We end up getting 3x plus 2 on top, and then x times parentheses 2x plus 3. Now from here, this whole thing was set equal to 1. So what I did was I wanted to get the bottom to cancel off on my fraction. Well, I distributed the x. I didn't really show that step, but I distributed the x and I got 2x squared plus 3x. Well, I multiplied the fraction by that and it goes away. There's no fraction anymore. And I multiply it to the right side and I just get that. Okay? So what you end up getting is 3x plus 2 equals 2x squared plus 3x. Well, subtract. I was trying to get 0 on the left side, so I subtracted a 3x and a 2 from that side, and everything's gone, so it just becomes 0. And then on the right side, you end up getting 2x squared, the 3x's cancel off, minus 2. Well, both of these have a 2 in them, so I factor out a 2. And then I got x squared minus 1, and this is that thing where the middle term cancels off. So what I did here is I recognized, oh, if I factor this, I'm going to get conjugates of each other. So I kept the 2 out front, and I had x plus 1, x minus 1. And then the two things that are going to make this whole thing 0 are negative 1 and positive 1. And that is my final answer. Okay? All right. This is going to be the last one I'm going to do on this worksheet, but 19, 17, 18, 19, these ones are all real tough. I think I did a pretty good job showing my work on the answer key, so just check it there. Okay, so let's talk about number 16. Okay, 16 is really, really similar to what we just did on 15, okay? I'm going to try and make well, I did this one in an alternative method, to be honest. I have a bottom of the fraction, I have a top of the fraction. I kept the bottom the same, but what I did is I multiplied it over to the right side. So what I did is at the very beginning, I canceled off the bottom of the fraction. So I multiplied both sides of this fraction by the 3 divided by x plus 1 minus 5. So I multiplied the left, multiplied the right. That got me here. The negative one out front, I'm going to have to distribute into the parentheses. So I got negative 3x and positive 5. And now I have a left side and a right side, and I kind of solved them simultaneously. Okay, so on the left side, I multiplied, I wanted to get the bottom of the fractions the same, so I multiplied the left one by x plus 1, I multiplied the right one by x, which got me here. And then I did the same trick over on the right, multiplied the right fraction by x plus 1 because the other one is already x plus 1, and I end up getting this. So now, I combined the tops on the left, combined the tops on the right. And then that was all in black. And then I recognized that the left one had a denominator of x times x plus 1. While on the right side, all I had was x plus 1. So I wanted to make those match so I could get them to cancel off. So I multiplied the right fraction, only the right fraction, by x over x, which is the same thing as multiplying by 1, which is why you're allowed to do it. So you end up getting x times x plus 1 on the bottom of both sides of the fraction. So if that happens, what you can do is multiply both sides by that, and it'll cancel off. So I cancel the left, cancel the right, here in red, and you end up getting 10x plus 4 equals 5x squared plus 2x. So very similar to the last problem, I just moved everything over to the right by subtracting it. So you end up getting 0 equals 5x squared minus 8x minus 4. Okay, so I looked at this and said, oh my gosh, I hope this factors. So I did 5 times negative 4, and I got negative 20x squared up top. The middle term is a negative x, so that goes on bottom. So now, 2 things that multiply to make negative 20 that add up to negative 8. Well, thankfully, there was negative 10x and positive 2x. Those 2 multiply to make negative 20, and they add up to negative 8. So I replaced the negative 8x in my problem with the negative 10x and the positive 2x. Group them together, factor out what I can factor out. You end up getting x minus 2's. So those match, which is good. And then the 5x plus 2 goes out front. So the 2 things that are going to solve this or make this whole thing 0 are positive 2, because 2 minus 2 is 0, and then the negative 2/5, which I was able to do in my mind, but if you need to write 5x plus 2 equals 0, solve it, you'll end up getting this, okay? So that is it for worksheet 4A. I would say the last numbers 15 through 19 are super tough problems. You know, those took me a while. It took me like a half page of work to show all my steps for that, but that's what I ended up getting, okay? Go through this worksheet, use my answer key a lot just to kind of guide you in your thinking. You know, if you're able to do this all on your own, that's awesome. I'd be surprised if anyone was able to do this all on their own, because these problems, you know, they're pretty involved and they have a lot of steps, okay? So email me with any questions that you might have. If you're not getting similar answers to mine, like I said, look at the answer keys and see where we're you know, diverging in our responses. But other than that, yeah, just send me questions through email or bring them to class and I'll be happy to answer them, okay? Have a lovely day, and I'll talk to you later.